This is a brief overview of the cooling system available with Rex Materials TCS, a high-efficiency barrel heating system for the plastics industry. The overall cooling methodology is that TCS heaters employ radiant heat rather than conduction to heat the melt, and as such, the heating elements are not in contact with the barrel. This creates a gap between TCS and the barrel. The TCS cooling system pulls air through that gap to remove the heat and exhaust it where desired. To facilitate airflow, cooling channels are cut into the TCS sections, and cooling rings are added on both sides of the system to both allow ambient air in and exhaust hot air out. The entire cooled TCS system then consists of TCS sections, the cooling rings just referenced, ducting, and a blower. It is important to note that the blower is configured to suck or pull the air out rather than push the air. Pulling the air through the system allows the hot exhaust air to be directed as desired. These images show cold air being pulled in through the cooling ring, over the hot barrel, through the cooling channels, and then out through a second cooling ring, being pulled by the blower. Again, the hot exhaust can then be directed where desired. Some companies choose to retain the heat in their facility, particularly during the cold months, while others exhaust it out of the facility to improve the working environment for their staff or reduce air conditioning load in controlled environments such as clean rooms. Cooling can be activated by machine control systems via the programming, and when this is done, each zone is typically controlled separately with its own blower. Blowers can also be set up to be manually activated, which is typical when the cooling system is used for rapid cool down, for material changes, or maintenance. A few notes on installation. Installation of the system is fairly intuitive, and visual instructions are provided with each kit. It is highly recommended to review those instructions prior to design or installation. But beyond the instructions, it's very important to simply consider the airflow you're trying to achieve during the installation to be sure there are no obstructions to that airflow. Cool air should easily flow in through the cooling ring and through the cooling channels of the TCS section. As such, the cooling channels of the adjacent TCS sections must be aligned. This transparent view of the system shows the channels of adjacent TCS sections. Notice they are well aligned, allowing air movement through the system. Another installation tip is that TCS sections and cooling rings must be installed without gaps between them to direct the airflow along the entire intended length of the barrel. Also, the surface area to be cooled, which is a function of the length and diameter of the barrel, will impact the number and location of blowers required to achieve the desired cool down rate. The more airflow provided, the faster the cool down. There are several design considerations when configuring a TCS cooling system. For instance, breaks in the TCS system along the length of the barrel must be addressed. Breaks can be caused by interference, such as barrel supports or rigging bosses. In this case, additional cooling rings must be added at the break point to facilitate the airflow due to the break along the length of the TCS system. When designing for rapid cooldown, the targeted rate of cooldown must be considered. As mentioned earlier, the rate varies with both airflow and the size of the surface area being cooled, which is a function of barrel diameter and length. A spreadsheet is provided on the website to estimate the rate of cooling. Simply fill in the blue cells to generate a plot of the cooldown rate as a function of barrel temperature. The actual rate will vary due to several factors, including material type and purge, but the plot provides a good comparative baseline. For larger systems, or when very rapid cooldown is required, additional airflow will be required. In this example, the system has cooling rings on both ends, but it also has additional cooling rings midway along the length of the barrel. This allows for 2 blowers on a single barrel, pulling air from 2 separate cooling rings, and exhausting through 2 separate blowers, which provides the additional capacity required. There are 3 levels of cooling defined for any single length of connected TCS sections. There's minimum, which has a single blower and a single outlet, moderate, which also has a single blower but pulls air from 2 ports, and maximum, which consists of 2 blowers pulling from 2 ports. An optional design approach offered with TCS is called Design for Future Cooling. This option allows a system to be designed without the rapid cooldown feature, but with the correct configuration so rapid cooldown can be added later if desired. It is very important to note that the rapid cooldown feature cannot be added to an existing system that was not designed for future cooling. Systems designed for future cooling have cooling channels added to the TCS section, and blank cooling rings added to each end of the system or to system breaks. The blank cooling rings are there both to secure space for the regular ported cooling rings if they are added later, and to seal the ends of the system, as the cooling channels on the TCS sections now leave the interior of the system exposed, which creates heat loss. Notice that the blank cooling rings do not have ports for airflow seen on the regular cooling rings. So a system designed for future cooling will have cooling channels in the TCS section and blank cooling rings. If you wish to add the rapid cooldown feature, simply remove the blank cooling rings, add the blower hardware, install the ported cooling rings, and add a blower. The blower can now be activated to pull air through the system and cool the barrel for material changes or maintenance. The blower specifications, shown here, are available online, either on the cooling page of the website or the resource page, as are the blower schematics. Shown here is an example of a TCS cooling system. This is an active cooling system, which means the blowers are controlled by the machine program. Notice that the blowers are mounted above the machine, cooling individual zones, and you can also see the ducting and the hardware going to the individual zones. This has been a brief overview of the cooling system available with Rex Materials TCS. Thank you for your time, and please contact your TCS representative for any additional questions.